Hello, everyone. Welcome to another episode of the Day Zero podcast. I'm Spectre. With me, as always, is Z. Today, we've got a bunch of vulnerabilities, some to do with Git, some with the F5 big IP stack, and some binary exploits, an Android kernel exploit, and some drama around proxy logon and the Microsoft Exchange attacks. So let's start with that first. So we'll start off with some drama, as we always do. So GitHub ended up removing proof of concept code that was posted for Microsoft Exchange vulnerabilities that made up the proxy logon attacks, which there's kind of an uproar about because people see it as, I guess, a conflict of interest and Microsoft abusing the fact that they own the platform to remove information that would be damaging to the company. So there's a bit to unpack here because there's more drama to this story than just what's covered in this blog post. So, getting to some of the meta details, last week on Patch Tuesday, Microsoft released emergency patches for the Exchange bugs that were used in the proxy logon chain, because it was discovered that multiple APT groups, 6 and possibly more, had exploited it in the wild, with as many as 10 up to this point. And already there's a bit of drama around that because these bugs started being exploited after they were reported to Microsoft and before Microsoft shipped the fixes. So people were wondering, is there a leak maybe inside of DevCore, which was the company that reported the bug? And then later on, people started thinking, was there maybe a leak from Microsoft's MAP program or their Microsoft Active Protection program where they allow partners to have exploit information ahead of patches? And that's kind of relevant here, and it's not really mentioned in the blog post. Now, getting to the core of the story, they noted that within hours of the POC going up on GitHub, it was removed. And the entire conversation here assumes that it was removed because Microsoft didn't want public exploit code out there for Exchange issues, since so many servers were already being targeted. And while that might be true, according to the Wall Street Journal and Bloomberg, Microsoft had started an internal investigation into whether or not Microsoft Active Protections program could be the source of a leak. And I think it's entirely possible that that could be connected to the takedown. Now, I don't want to say for sure 100% that that's, what happened because I don't know. That's speculation. But that is a potential angle that I think a lot of people aren't even considering or might not even be aware of.
I find it a little bit unlikely, personally, that the proof of concept code that was published on GitHub would also be the same that would have been leaked or that could be taken down under a copyright. Part of that's because if it was that sort of takedown, DMCA, it's copyright issue, because if they're leaking it out of the active protections group, that's going to be a copyright file that gets leaked, so that could be taken down with DMCA. They didn't take it down using a DMCA claim. So I don't feel like that's likely. I kind of land, so they do actually cover in the news post here kind of two perspectives on Travis Vermandy. I'm not sure if he was commenting directly to them or if it's just a general comment, but he makes the claim kind of aligning it with, is there a benefit to Metasploit, or is literally everyone who uses it a script kiddie? In that case, it's the same idea, publishing the POC, it's being put out there. That debate has been ongoing for many years in terms of, should we release these weaponized scripts effectively to the broad community? And there's a general consensus, although not a complete agreement, that you're generally better off by releasing this information to everybody rather than trying to hide it to just the select groups of people. But there's also kind of the comment from, I believe it's Marcus Hutchins. Oh, I believe it's Malware Tech. Somebody can correct me on that.
It is, yeah.
Yeah, and he mentioned that, I highly doubt Microsoft played any role in the removal. It simply fell foul of GitHub's active malware or exploits policy. I'm kind of leaning towards that, and maybe that's just me trying to be more charitable towards people. But I kind of would lean towards saying, there have been other exploits that have impacted Microsoft products that Microsoft has not taken down the proof of concept of. I don't see why they would start with this one. I mean, it is an Exchange issue that is a pretty big deal, like the last pre-auth RCE in Exchange was what, like 15, 16 years ago? Or impacted, at least something from that old. I'm not sure when it actually came out, because I know it was part of like NSA, like it was part of that leak. So I mean, it's a big deal, but at the same time, it seems odd to say that Microsoft would have really targeted this one specifically. Like, I feel like there's more going on than just Microsoft trying to silence this one.
Yeah, so personally, I tend to fall on the side of public disclosure. I'm in favor of write-ups and POCs and stuff being released. And, like, in fairness, this was put up after the issues were fixed. So it's not like, it's 0 days were being put on GitHub or anything. Um, but this is one of those circumstances where having the exploit code out there can be extremely damaging, especially when most systems, like most servers, haven't been patched by that point. Um, and it's pretty much a given that this is going to end up getting used by nefarious groups to hit those servers, of which there's many out there. And I think people are blowing this out of proportion a little bit. People are taking this as if it's the canary in the coal mine and it's the beginning of the end of research code being posted on GitHub or Gis or something. And I just don't think that's the case. I think this is a very specific scenario. And whether it be for the leak, which I mean, you're right. I think it's more likely that it's just because I think it's mostly just Microsoft trying to protect their customers, and whether or not that's fair, like I
I'm
think
not
it
even
is
sure
fair.
it's Microsoft behind it. Like, I mean, obviously Microsoft owns GitHub, so technically it's all Microsoft, turtles all the way down. But ignoring that aspect, like I could definitely kind of see, as Malware Tech mentioned here, like the idea that it could just be GitHub's policy, and that like just because of the fact that it's an active exploit that it was taken down, rather than the fact that it's Microsoft or Exchange or like anything personal. So like, sure, technically GitHub is Microsoft, but like they would have acted the same way with something else also, is kind of what I'm getting at. I don't know what exactly made this one special, because obviously there are plenty of proofs or POCs that are put out there. So I'm not sure what made this one special, but I kind of would take that hunch. If I want to get worried about something and want to see this as something to be concerned about, I'd be looking for a pattern of this sort of removal. So if, say, next week we find out GitHub also start taking down other POCs and we start seeing this pattern of them removing them, then yes, I would start to be very worried that there's that pattern that they're doing it. But a one-off, I'm going to hope that they'll comment on it. I'm a bit surprised that I haven't seen a comment from GitHub about this. Kind of explaining what made that one special. I'd be looking kind of for that, though. Lack of it's a little bit concerning, but I mean, it's not. We are kind of a niche community, so the fact they're not pandering to us is kind of fair.
Yeah, I agree. I think people really jump the gun on this topic and kind of taking something where they don't know the full story and running with it.
Yeah, I definitely would
Like you
keep my
said,
eye on it. Like, there's the potential. I think you always need to be worried that they are going to start censoring those things. Like, that's a fair concern. I just would want to see a pattern of that.
it's also like, as much as there might be a concern around that, um, GitHub security stance doesn't seem to align with doing stuff like that. Like they're generally pretty open. I mean, hell, they have their security lab running where they put out blog posts on vulnerabilities. Like we have one in this episode, actually, the Android kernel exploit. So it's like it's not like they have an anti-security perspective. So it seems unlikely to me that it would ever go that route. So I think people are being a bit uncharitable.
Yeah, I'd agree. And yeah, their security lab is definitely, even beyond just the blog posts, they do a lot of vulnerability write-ups that we don't cover.
Yeah. Up next, we have a story that's an issue that's a little bit of repeated history when it comes to some of the things we've covered on the podcast before.
It's repeated, but let's be honest, you're hacking cameras. That's just kind of fun. They're injecting video into cameras, like the movies.
It is fun, I
It's
agree.
just a cool exploit regardless.
Yeah. So this is about a cheap CCTV IP camera, the V380 Pro, and some vulnerabilities that were found when they when these researchers looked into it. The bugs themselves are pretty memeable, as is the case with IoT stuff. But like Z said, the attacks are pretty cool, and there is like a Hollywood kind of aspect to it. These cameras have kind of your run-of-the-mill smart capabilities. It's got an app client for mobile and desktop that you can use for like configuration and viewing. And to facilitate that, it has a backend master and relay server. So to facilitate streaming the video, the client submits credentials to the relay server, which it then sends over to the camera for verification. The problem is when those credentials get submitted, or actually like any communications with the relay server, they're in plain text. There's no TLS or anything used in communications between the client and the relay server. So because those communications aren't encrypted, not only can you pull credentials by packet sniffing, you can also inject a fake video feed. And that was really cool because, like you said, it's an attack you see in movies a lot. You know, when they're doing a heist or something, and they hijack the security feeds to not alert the security department. Except here, it's an actually real attack. It's not camera magic, right? Um, there are a few other noteworthy things they found. One of them was there was no authorization required on LAN, only on remote access. So if you were like in on the local area network, you could um, like pull off attacks on that basis. Um, the other thing is when configuring the device, the camera sends the Wi-Fi, SSD, and password, or SSID and password in clear text to the relay server. And again, those packets aren't encrypted, so you can pull them. Um, they end off on that note stating it's possible that you could, like, that could end up opening more attack surface that you could look at, but they kind of leave that as an exercise to the reader, so to speak. They don't really go into that too much. But yeah, I mean, this is one of those attacks where it's like the bugs really aren't that interesting. It's just a kind of a joke,
I mean, they
really.
cover
But
technically these 4 different bugs. Realistically, I'd say there's really only 2, I guess. 3 of them fall under the fact that they just don't have any TLS. There's no encryption over the packet, so all the data's in the clear. Thus, you can inject video frames, or you can replace the whole video feed. That way you can see the credentials being sent to authenticate, or when you're configuring the Wi-Fi for the camera, the relay server will send like the Wi-Fi SSID and credentials in plain text to the camera. Like, it just does that in plain text. So the issue is really just the fact that they don't have TLS. I mean, they can't use HTTPS, but they can still have TLS on there. The other one being like the local access. That one's a little bit more tricky because that's just accessing the video feed directly, like the RTSP feed directly. So that one, like, a fair point to call it out, like maybe not exposing that too publicly or requiring token to start it or something like that. There are ways they could secure that one. That one wouldn't be fixed just by having TLS. But the rest of them, it's just because of that, everything else becomes possible. But yeah, it's not that interesting. Like, it's a reasonably common thing, but because of the environment, the camera, still kind of cool to see.
yeah, yeah, I agree. It's mainly just the cool attacks. I was just reading something from chat saying, sure, I think it kind of contradicts the things GitHub stands for. Security vulnerabilities and exploits have always been shared on GitHub for ages. Yeah, exactly. So yeah, we'll move on to our next topic. Up next, we have a CSRF and Zabbix, which is a solution that allows monitoring for IT, like monitoring the network, services, applications, what have you. And this application has an admin panel, which allows you to do some very sensitive things, such as set up scripts that'll get ran on the server proxy, or the Zabbix agent software. So because of some of the sensitive things you can do in the admin panel, they do try to prevent client-side request forgery. They use anti-CSRF tokens that are passed through either the request header or the request body. But there is one area that they fail to check the token. And funnily enough, it's when updating the authentication method between internal and LDAP, which is short for Lightweight Directory Access Protocol. So it takes the LDAP server information from that request. So an attacker can use it to make it authenticate using an attacker-controlled LDAP server. Now, there is another thing worth mentioning here that kind of makes this attack possible, and that's the fact that they don't set any cross-site cookie attributes, so it defaults to the lax setting that browsers use. If they would have set that cookie attribute to be strict, I don't think this attack would have worked because the session wouldn't have been able to carry over. It wouldn't have sent the session cookie over. Um, where it is lax, though, the cookie can get sent with GET requests because they're generally considered safe. And that's to allow things like loading assets from like a script or images on the client side, for example. Um, and the other thing is, for some strange reason, the GET requests are accepted by the backend server for these form submissions. It allows both POST and GET requests. And both of these things combined contribute to making this issue exploitable. Because
Yeah,
you can make the requests over GET, and those GET requests have the cookies attached to them.
yeah, and that fact that you can use get instead of post, like there's so many websites that do that. I strongly disagree with ever trying to implement that, but it is kind of common. I think we talked about quite a few episodes back too, where I was talking about the fact that you can sometimes include a parameter that'll tell it, like, treat this as a post request or something like that. I mean, in this case, it just works that way. It's just a weird feature. It happens a lot. I understand in like a development environment, it's easier just, be able to change the URL a little bit instead of going through the whole form or whatever. Nonetheless, I mean, just try and avoid that, please. Because it just makes things so much more beautiful. That said, like you mentioned the same site attribute, and that is really kind of aiming to severely hamper cross-site request forgeries. Because if you can't do the post, so many things like do require the post. So if you can't do that, same site kind of blocks the entire CSRF aspect, which is a common vulnerability that will probably be disappearing a lot more as more sites. Or I guess it is default now, or it has been default in Chrome now for a bit too. So
Yeah, I mean, it is a strong protection, and I think like what I took away from this post is how useful defense in depth can be. Um, because while these other things on their own, like not setting the cross-site cookie attributes, might not be an issue, they would have mitigated this attack. So it's just a highlight, I guess, on how defense in depth can be super useful and can prevent attacks entirely, even if you do have vulnerabilities, like you were saying with how they're trying to kill CSRFs with that. So yeah, in the end, they changed that bug with the ability to set up scripts to get RCE. Turnaround time was pretty quick. The issue was reported on January 3rd and fixed on the 13th, with releases being shipped on February 22nd. It's also worth pointing out that this issue does require some specific circumstances to exploit. Not only is there the obvious requirement that the victim has to navigate to the malicious page to in order for the CSRF to work, but also the Zabbix instance has to be able to reach out to the attacker LDAP server as well, which generally I would think you like wouldn't really have something like this exposed to the wide internet. But then again, a Shodan search showed that there were at least 20,000 instances that were accessible on the internet. So yeah, but
oh no, I mean the idea of this though is having that single point of management, so exposing that to the internet so you can manage everything kind of internally without exposing all of those also. I can understand why it's exposed on the internet. And just being lazy at times.
yeah, I mean, laziness is the ultimate killer. So,
And you kind of mention it, but I'll just reiterate here, like getting command execution in this case after they had the CSRF, they changed the auth server to use the attack controlled LDAP server. At that point, code execution is literally a feature, which without removing the feature, like I'm not sure what they really could do to prevent that.
yeah, I don't think it would be fair to call that a bug. That's just it's one of those things where it's intended. You're pretty much entirely relating on or relying on the authentication, and if that's broken, you're screwed. And we have another topic that's kind of related to that coming up soon too, where we'll get into that.
Right, thank you, Ash Fox, for the raid.
Oh yeah, awesome, dude. 48 new people. Welcome in. So let's jump into another web-related issue. We have Froxlor. This one's less about the vulnerability involved and more about how you can take advantage of a vulnerability when all seems lost. Um, so this post is around a cross-site scripting bug in Froxlor, which is an open source server admin panel. Um, and the bug is basically when they reflect the customer email get parameter into the page for an error message, when it fails to send an email, they don't do any like sanitization on that. While you could inject contents into the page using that, smartly, Froxlor sets a content security policy that disallows the execution of script tags and inline scripts, and also avoids loading external scripts from third-party domains. So again, it's like that defense in depth, right? There's an issue, but it's hard to exploit because the defense in depth makes it so you can't just do like a script alert or something. Um, so it'd be easy to think like, well, that's it, that's that. Let's just move on.
Yeah,
After
I mean,
looking into it a bit more, they did discover a way to exploit it, though.
in a lot of cases, you can definitely just report this much and still, like, get a bounty or something. So, like, it is a fair stopping place. But I appreciate, like I said, they did kind of start looking into it a lot more to see, okay, well, how can we still exploit this or actually get something useful? Ultimately, the trick they used was just basically they can still inject HTML, they just can't do scripts, and they happen to be on the login page, so effectively they end up making the page post the login to their own controlled location. Doing that through a base tag, which just specifies what like the base URL to use for the page would be. So specify a new base tag, give that the URL as like the attacker server, and then when they have any relative URLs, it's going to be relative to that base tag, which will be the attacker server, so it sends all the logins out to them. Which I'm quite sure we haven't talked about anybody doing this. I'm not sure. Do you recall seeing this before?
I don't think we have. I know it's a known like technique, but I don't think we've ever covered it.
Yeah, it's not a new technique, but I don't think we've covered it at all. And yeah, it's one of those things that's super easy to forget about. Like I8BR mentions there, I always forget about the base tag. It's just kind of the same thing. Like I'll read about it in something like this. I'll remember it. I'll be like, yeah, I need to remember that next time I run into it, and then I just forget about it.
Classic. Yeah, I mean that's pretty common, I think. So yeah, using that base tag, they were able to make it so that like credentials would be submitted to the attacker URL, not the legitimate host, for example. The way this was fixed, in air quotes, or rather mitigated, was to introduce anti-XSS, which is an open source PHP-based protection for XSS. They state the actual bug is still present, though, and it's possible it could be exploited in a different way. They suggest something like script gadgets or something. The author kind of leaves that in the air, though. They don't investigate it further. In conclusion, I will say it is strange to me that they wouldn't just like fix this bug outright. I mean, sure, bringing in anti-XSS might not be a bad idea, but like fix the issue as well. It should be a pretty straightforward bug to fix, but yeah, I don't know. It did like strike me as odd. Maybe they have fixed it by now, and that was kind of a stopgap, but I don't know.
Yeah, now that you're mentioning it, like there is all it's doing is setting the message. Like they should just be able to escape the email value, and that should be fine. So I wonder what their reasoning was to say, okay, let's not just use like HTML entities, which is just a function you could literally wrap that line of code in, the CMail assignment. I guess if they have to use that later, which is probably why they're doing that separately. Yeah, I don't know. Like, I don't see a good reason just in this code as to why they would decide, yeah, we should just add a new library instead of just using the normal fix, which would be using HTML entities. Just escape it.
Yeah, it's really weird.
Out of chat, IABR is all saying, in this case, shouldn't setting an absolute post address solve the vuln? Base only changes the base for relative links. That's correct, but I mean, the vulnerability is the HTML injection. So that would only solve the ability to redirect the form post itself, which I suppose your next case, kind of inject your own form, add a comment to escape out everything after. the message, you could maybe still come up with a pretty convincing login page that would post directly to the attacker's website instead of using base to redirect it. So, I mean, I'd say, like, yes, that would fix this particular case, but I think it would be better to focus on fixing the actual injection.
Especially since it should be so trivial.
Yeah, like, somebody had a reason for this. I don't know what it is, but somebody must have looked at that and been like, okay, let's use this library because they don't like the normal way of solving it. Like, there was a reason for it. I just can't figure out what that is.
All right, so let's move on to our Git topic. So up next, we have an OpenWall report about Git and how malicious repositories can execute remote code while cloning. So I saw this circulating a little bit around on social media. So Z, I'll let you take this one away.
Yeah, and this one is fundamentally, it's a fairly easy bug to actually understand. It's the exploitation that gets a little bit more tricky. And I've got the report open up, and in the description we'll have a link to the fix commit, which is a little bit of a better explanation on the technical side of things, because this report itself really just shows like the demo exploit. The actual description is on case-insensitive file systems with support for symbolic links. If Git is configured globally to apply delay-capable clean smudge filters, such as Git LFS, Git could be fooled into running remote code during a clone. That doesn't really tell you what the vulnerability is. It just gives you, I guess, the situation for it. Like, it's useful information, but I'd want to cover more, I guess. So that fix that I added to the description includes a bit more of the technical details. But as I was saying, the fundamental issue is pretty straightforward. All it is Git, as it's checking out all the files, for all of the directories, it will do an lstat, and it'll cache that lstat response. And what it's doing there, or at least part of what it's doing with that, is it's going to look when it's checking out a file. It'll take a look and see if the location that it's writing to, so all of the parent directories, if those are symbolic links, and it's not going to write a file through a symbolic link, which should be expected for security reasons. It doesn't want to do that. So it uses this lstat cache, though, in order to prevent it from being to make all those lstat calls like every single time it has a file. So, I mean, that'll add up over time with some Git repositories have a lot of files to go through. So it just gives you that quick access. So the problem is, though, on a file system, when it's case sensitive, you can have a file called temp, all lowercase, and like capital T temp. And those would be two separate and distinct files. Whereas on something like NTFS on Windows, which is case insensitive, it'll treat those as the same file name. So you can kind of have a collision where the Git repository might have two files with distinct names on one file system, but they clobber each other on another file system. When this collision happens, that internal cache I was talking about doesn't get properly updated. It'll still have the old value. Usually this kind of disconnect between what the cache says about a file or directory and what it actually is doesn't end up mattering so much because, I guess actually ignoring that aspect, so exploitation of this, if you can kind of clobber that directory with a symlink, that cache will still say it's not a symlink, so you can get Git to write a file through a symlink, effectively giving you this arbitrary file write. If you control that symlink, which of course you do because you control the repo. But that's kind of easier said than done, simply because you need to control the order all of the files are being cloned in. So normally these clones will happen in kind of the index order, like a depth first traversal. That is, it'll finish all the files in one directory before it carries on back up in the parent, where you can have that potential clobber happen. So even if you can clobber it, can't really do anything with it because it's not going to be writing anything to that directory anymore. You could overwrite it, cache will be wrong, but it doesn't matter. Nobody cares. the problem is if you can somehow get Git to delay writing one of those files in the directory. And that's where the description talks about a delay capable clean/smudge filter. If that filter process, which is just a process invoked on every blob that's affected by a filter, if that returns saying its status is delayed, Git will just kind of give up for a bit, postpone extracting that file, writing it out, and it'll carry on with everything else, which means you kind of have this file written after that clobber happens, if you're able to cause that at least. So this allows for the clone to carry on. It'll clobber the directory. You can replace it with a symlink. It'll go back when that filter's done, write it, giving you an arbitrary file write. Using the arbitrary file write, you can then do or overwrite any file you want, such as in the example case, they use the post checkout. So you can set a post checkout script that'll run after the checkout happens, giving you code execution. Does require kind of this specific circumstance, which is default in some cases, but not all of them. But yeah, I think it's an interesting vulnerability.
I like the basis for the bug. I think it's pretty cool. It's unique.
The bug's cool. I'm not sure about the real impact of it. Obviously, there are cases where it can be abused. I think a lot of people do run Git on a case-sensitive file system. Linux. Most people on Linux with exe will be on a case-sensitive system. It is possible to configure it to be case-insensitive. So, it's an option there, but
I don't know if anybody actually does that. I know I haven't.
I'm sure some people do. So, it's worth being aware of. Obviously, any Windows users, NTFS, case-insensitive, could have had this exploited against them. I think it's a cool bug, but yeah, it seems difficult to actually exploit.
So I did want to pull something out of chat, but first, thank you, RealRBX, for the tier 1 sub. Appreciate it. But yeah, I wanted to pull something from Rudamal, who put in there that they were thinking of the submodules thing, CVE 2018-11-235, with a follow-up to the previous comment being, didn't something like this happen already? Yeah, there's been a few Git issues. I don't think we weren't really doing the podcast back when the submodules thing was published, but we've covered a few other Git attacks even on the podcast before. Not an exploit like this where you can get corruption of a file or something, but there was also a new line injection in the credential helper protocol for Git back in, I think we covered that on episode 38. So it was a long time ago, but yeah, it's always fun to cover Git issues because they are Git is really common in our space, obviously. So, although in the case we've covered, including this one, exploitation is pretty difficult. And it might not be overly practical, but still, it's worth being aware of. So, we'll move on to Dell. Next, we have an issue in Dell's OpenManage server administrator, which is an agent for server admins to be able to connect to and manage server systems from a local or remote context. And it uses servlets and Apache Tomcat to facilitate those actions. The bug is an authentication bypass issue, which has been known for a long time now. There's been a public repository up from Harrison Neal, who's another security researcher. And that repository has been up for at least 5 years, going off the repo information. Dell brushes it off as intended behavior, which means it's still not fixed. And unfortunately, I could kind of see how they would say that, but we'll get into that in a second. The basis for the authentication bypass is when you go to log in, you can choose the ability to authenticate using a central server, so that you could authenticate into remote systems using a single web interface. And that's through a feature called the distributed web server, which is a functionality that's enabled by default. The problem is usually that web session is only used for rendering content from the remote node. But in versions 9.4.0.0 and 9.4.0.2, it could also access privileged APIs for some reason. I'm not really sure why.
And
Maybe they
apparently,
just needed a new feature and was lazy.
well, apparently also that was, working as intended.
Yep,
Which I
according to
found
Dell.
to be it's just like, yeah, privilege. Well, yeah, basically bypassing authentication. Yeah, that's what we wanted. That's the point.
Yeah, it makes me think it was literally just like they wanted to add something and they were like, screw doing it through proper channels. We'll just make it so they can access the APIs.
Yeah, I mean, it's basically they're trusting the hosts. They're trusting all of the services where their host application is installed. They're trusting it. Like, they're just assumed to be allowed. In this case, you're just pretending to be one and abusing that. So, like, there's a logic to it. Again, tokens would be a fairly easy way to add some authentication behind this. Easy enough to steal, but add something rather than nothing. And I will
you're at
call
least putting a
out,
lock on the gate instead of leaving it wide open.
I will call out Real RBX also gifted a tier 1 sub to Mason 3161. So thanks for that.
Yeah, so like you said, by hosting your own malicious server and authenticating yourself, you can give yourself a web session that can access privileged APIs. One of the servlets that's accessible from that API is the download servlet. Now, the blog post authors call this a file read vulnerability because it'll take a file parameter and download that file, and there's no, there is a very, very weak filter on it. They don't allow you to download like one file, I think. At first, I wasn't sure if I would have called that a vulnerability because it seems like a reasonable capability to expose to authenticated server admins. I think the bigger issue is just the fact that an attacker can reach that endpoint in the first place. That said, Dell did take the report and try to address it by adding additional filtering to prevent pulling certain files and certificates. Now, of course, if you look at the check in the code snippet, it's not very good. It falls into a category we talk about a lot, like blacklisting not being a great defensive strategy. So, as you can probably expect, this was bypassed because it doesn't take encoding into account. So you can literally bypass the filtering by using URL encoding, which is just it's just kind of meme worthy. But so they again tried to fix the issue, and it's implied that they have finally fixed it properly, though the article doesn't state that outright, but they don't say like that one was broken or anything. But yeah, Dell still considers the authentication bypass intended behavior, and so it still hasn't been fixed. 5 years running. So, and it's kind of funny if you take a look at the repository for that authentication bypass that was mentioned by Harrison Neal. The README in the Git repository shows directly like, hey, this should be used for like fuzzing or security research. That's a good way to use this, is fuzzing the privileged APIs. So if you're looking for more bugs that you might want to find and abuse, you can check out that repository and use that to look at other APIs. There's more than likely other issues in there if considering like how the powerful capabilities they expose to server admins. So yeah, could be a fun exercise for anybody out there looking for something to do.
Yeah, I mean, probably more kind of low-hanging fruit vulnerabilities to be found. I mean, when there's one like that, especially in how they patch the file disclosure thing. Especially when you see that just kind of gives a sign towards what you're going to see with the rest of it.
It's a red flag.
Yeah.
All right, so up next we have two vulnerabilities reported by James Forshaw from Google Project Zero and Windows Container. The first one is like really trivial. In Windows 10 20H2, the container user has elevated privileges, essentially making it an admin equivalent, which is super weird because the entire idea of having a container user and a container administrator is that the user can be restricted. But since they're both created using virtual service accounts, they're both granted the SE impersonate privilege permission, which you can abuse pretty easily to get system by using publicly available exploits. One they point out is rogue WinRM. So yeah, it just seems like an oversight, I guess, that led to a permission bypass.
Well, like you said, I mean, it's the container user and container admin. The container user can be restricted. And I see IABR and I had kind of the same thought. Emphasis on the can be, not, should be or will be,
Well, should be is probably still true, but
should be is probably true. It's just, it can be. You can totally go ahead and restrict it. They're just not going to do that for you. Yeah, I mean, it does seem like an oversight. It's a pretty straightforward bug. It's just overly privileged user that probably shouldn't be.
yeah. The second report does get a little bit more complicated, and it involves the virtual registry provider. So containers need to be able to access the registry for a lot of applications, such as Docker is one they point out. But you don't want to give them control over the host registry, ideally, because an attacker inside a container can do a lot of damage with that kind of control. So Windows tries to mitigate that risk by getting a global object manager symlink to a registry root key from the VM compute service, and then it layers hives on top of that. So when it goes to access a key, it'll first check for the layered hives and return those instead of the root registry key. The problem, though, is if you open the registry path using relative paths, like \registry, and then open machine relative to that root, the registry provider ends up providing the host registry key and not the virtualized key. So that can allow somebody to get access into the host registry, which is still somewhat limited because you are limited by the access of the current user. But they could potentially, they could use that as a foothold to escape the silo or container.
Yeah, well, it just shouldn't happen. Like, the whole point of having the virtual registry provider and having that silo is to keep it inside of there. So the fact that just use a relative path and just kind of do that one at a time, opening registry, opening machine, and going from there, like just do that and you can escape it. Like that just shouldn't happen. They don't really dig into how or why this happens. In the write-up here, Forshaw says, like, it either ignores or gets confused and opens the host registry key, not the virtualized one. So that's about all the detail we have. We do get a proof of concept code. It literally just it creates the registry path that it wants to check, compares the number of elements in to prove that it's in the host or in the virtualized one. And for exploiting it, literally just splits the string and calls all the relative paths on it. So very straightforward and easy issue. It's not much more complicated than the last one.
Just another oversight leading to the functionality that they were intending being broken. So let's move into some more interesting exploits, some binary exploitation. Continuing with some Project Zero reports. Again, 2 reports, this time both in the F5 Big IP Application Security Manager, which is used for traffic management for internal infrastructure and stuff. This one's a buffer overflow in a routine that evaluates HTTP headers for login requests as part of the web application firewall. It tries to limit the length of HTTP header names that it accepts to a limit of 8192 or hex 2000. And it does that by extracting the header into a stack buffer and adding in the separator bytes, calculating the length of the header name and limiting the header value length by setting it to 8190, subtract the length of the header name. And it limits it to that if the provided value length is too large.
Yeah, well, I mean, it's basically calculating the remaining space in that buffer.
Yeah.
You're describing the math, but the gist of it at that point is just saying hey, whatever space the name of the header didn't take up, subtract that from the total size. Well, it's not actually the total size, which is actually where the issue comes in, but subtract that from the total size that we were allowing for it, and then read into it. And I guess carrying on, the issue comes in with that size. You'll notice that it uses 8192 up at the top. It has that default of going to copy in 8,192 bytes. Unless the length of the name is less than that, then it'll use the smaller size. Then it goes ahead and figures out how much space is, or then it adds the 2 characters to separate the header from the value, the colon and a space. And when it does that calculation, it'll use that end length again. So that could be 8192, and it subtracts from 8190. So you can potentially end up with a negative number, or because it's unsigned, that's just going to underflow all the way back over to the uend max, which then you have a very large value being used as the length to copy and a straightforward overflow. Sorry to have kind of hijacked your description there.
Yeah, no worries. That was good. Now, like the vulnerability is pretty trivial here. It's a stack overflow due to int overflow.
Technically, int underflow in this case. It is going down past 0, but same issue, more or less.
But the problem is, like, this wouldn't be a bug to hit very easily because it requires the ability to control HTTP headers, which is a pretty high bar. But they note there are some scenarios where this could still be exploited.
So headers in the response, coming from the backend servers, you do control the headers you send out forward. The other thing is that, the lack of like ASLR and deb make this easier to exploit too. If you just had a stack smash, you'd also need an infoleak. Well, I guess it depends what's sitting on the stack up above it. In this function itself, you might not actually, because you've only got the character and the couple length values, but
because there's no stack cookies too. So
yeah, that's what I was saying. Like something in the stack higher, you might be able to overwrite still. Like earlier in the frames, you might be able to get something there. My whole point, though, basically ends up being the lack of mitigations also kind of adds something to this, because this can be exploited because there aren't those mitigations. If there were mitigations, like even ASLR, ignoring the rest, even just having ASLR here would make it something that you'd require at least a second exploit.
Maybe not. You could do a partial overwrite. Potentially.
Yeah, like well, that's what I was saying a little bit before. Also about the other things to overwrite if you weren't just going to target a like RIP overwrite.
Oh yeah, okay.
That's kind of what I was getting at. Like there are some other options, but having those mitigations would have made it like much more difficult to exploit. Sorry, I kind of hijacked us there. Like there are, so jumping back to kind of the exploit scenarios, this is also backend services that need to be doing this. So there are cases where you might be able to control it, as mentioned, the HTTP header injection, maybe request smuggling, or if you just compromise the backend server, then obviously you control what's going to come back as a response. So I see it as a reasonable, like it's something that could be done, like as a further step. So you compromise the network, or you compromise a system in the network, and then compromise kind of the big IP system here, and then use that as your foothold to other networks. So like I could see an attack using it.
Yeah, thank you for pointing out the fact that it was response headers, because you can't obviously control the request headers. I kind of misworded there, so
yeah, like I know you knew what was going on there, but for listeners, triggering it is complicated. Exploiting it seems fairly trivial.
That's a good cap to put on it. Yeah.
Well, so instead of just capping it there, like, what are your thoughts when it comes to these IoT devices not having the mitigations? So we can comment on, like, this is bad code. Plain and simple, it's bad code. Nobody, I think, is going to argue with that, but really, I feel like these IoT devices should be having the mitigations also.
So I was wondering, do we want to save that for maybe after the next topic, since it's the next topic is also F5, and then we'll do like a summary thing? Okay, so we'll do that. So the next F5 topic, the second report for it details an info leak and an out-of-bounds write when handling IPv6 host names in the IP6 traffic management microkernel, specifically when it tries to normalize URIs. The info leak is based on the fact that if you pass an address that's shorter than the expected length because of that normalization that happens, it doesn't error out or initialize the full IP structure to 0, so it'll copy uninitialized stack memory into the host name. The other problem is that because the normalized routine will use that uninitialized data, any assumptions on the size of the normalized URI are also broken. Because it's expected that a normalized URI is never larger than the input length times 3 plus 2. And the reason they have that like times 3 plus 2 is to try to account for like URL encoding and trailing slashes. But in the example they provide, you can end up making it so that the normalized URI ends up breaking that assumption, right? I think the example they give is like a bracket and then 1 byte tail bracket. And then when that gets normalized, it leads to this full address because of that uninitialized usage. So, yeah, I mean, that assumption being broken gives way to the out of bounds right. It does require a specific configuration to expose this bug because most places that use URI normalization don't use it on the host name, but they do provide an example I rule that could lead to this bug being exploited, for example. But this seems to be one of those scenarios where it might not be hittable in like a practical sense, but it does still exist, right? So that's why
It
they wanted to point it
exists,
out.
but let's just assume you can hit it. How do you exploit this one too easily? Like you don't.
It is tricky.
It's an info leak, so like you get some information out of it, fact based on initialized information. So like there's a reasonable chance that you might be able to leak like a pointer out of that, like a code pointer, because you'll have these saved return addresses perhaps sitting there. So like there's that usage.
You are going to be very limited in like what you can do in terms of influencing, like trying to spray something to leak. Like I don't see how you might be able to do that, but it would be tough, I think.
Yeah, I think exploitation, besides just the fact that it's an info leak, would be difficult. Now, the fact that it's, I might log that and leak it somewhere, like you're not getting much exposure of this information unless you're able to see that log already. At least in this example case. So
Yeah.
it does seem pretty difficult to exploit to me.
I would say that this would probably not be practical to exploit, but it is kind of a cool issue.
It could be fun though, like to try it. Like it seems like it would be an interesting challenge to try and exploit it.
Could be, yeah. I mean, it's fun to see because you don't see a ton of issues, or at least we don't cover a ton of issues that are related to uninitialized memory. It's just one of those bug classes it's not seen super often, unfortunately. And it's unfortunate because it is like a fun bug class. You have that, you know, thinking of how you need to spray control data into the leak area. So yeah, I mean, I like that bug class, but we don't see it a ton compared to other like issue classes.
Yeah, I mean, maybe compared to some, like it definitely still is around. Like it's not like it's not a dying breed or something in terms of the exploit classes. But yeah, maybe not. I think part of that's just going to be because of like the code execution, the privilege escalation is kind of the more interesting topic to go on versus the info disclosure. But info disclosure is still a very important type of bug, especially with, as I was saying earlier, ASLR being in play a lot of the time.
Yeah, I think uninitialized use is kind of unappreciated because of that, where, code execution is like the meat and potatoes of the meal. And, the info leak is kind of just left off to the side. So, yeah, it's fun to see those. Now, getting into what you were talking about earlier with IoT and mitigations. So, yeah, I mean, I've seen the arguments that, well, you can't expect them to use exploit mitigations because they're like low power and it'll affect the performance a lot more. I think that's kind of a BS argument, if I'm being honest. I mean, a lot of these mitigations that we're talking about, like stack cookies, ASLR, they barely, if at all, really impact performance nowadays with how good computers have gotten. Maybe back in like the 2000s, that was a good argument. I don't think it's a good argument now.
Yeah, I mean, it's a fair argument, I think, when we're talking about something like stack canaries, or if we want to talk about like shadow stack or software CFI implementations, like things that happen in software. I think it's reasonable, but as far as I can tell, this runs on x86, like it runs on Intel chips. It can be run as a cloud appliance, so like it's not always just like their specific piece of hardware. I couldn't find out exactly what it was running, like in terms of operating system, but it seems to be based at least on on the Linux kernel. So like it has these things. It can do these things. I guess ASLR performance, maybe you can argue that like that is kind of a software thing technically. It's not hardware backed. But
I mean, the
that has a
performance
pretty
impact
minimal.
is so minimal.
Yeah.
Right, because
Oh.
ASLR, it's basically just the only time any performance impact would happen is on process launch when it's like creating, like setting up the virtual address space.
Yeah, like most of the time I feel like more likely the issue is like they're using some really old code that just, maybe they're sitting on a Linux kernel from like 2 point whatever or something. And like that's what they're running on. That's what they're using. And then it's like, okay, so we were doing this at this time. So like they haven't updated all of this old crufty code. And that's why. But like, I think we should be expecting them to, especially when it comes to these, basically perimeter defenses. Like, I think we should be holding them to a higher standard. Now, that does include like code review and making sure they're writing better code in the first place. But these mitigations like should be more or less default. Like, I don't think in most cases there's a good reason not to include them, especially when they are available. If they happen to be on hardware that didn't have it, obviously I can understand why they don't have it. I would push for them to use better hardware then, but whatever. But in this case, like it should at least be an option.
It feels like IoT gets a pass a lot when it comes to security, not just on mitigations, but on everything. All these, like a lot of the more popular software, or like a lot of the more popular product areas when it comes to technology, like let's say like browsers, operating systems, all that stuff. There is a reasonably high expectation of security on those. It's expected you're going to be, like, if you're a big company, especially, that you're going to be running some kind of bounty program or vulnerability program. You're going to have internal security teams. You're going to be doing code review and some, test-driven development, including like fuzzing and all that kind of stuff. Whereas with IoT, it's like you have this garbage code, and everyone's just like, oh, it's just IoT, whatever. It's, that's expected. Which, I mean, it is unfortunately expected, but it shouldn't be that way. And the fact that nobody's really pushing back on that and kind of demanding more from like IoT developers, I guess, or IoT companies is really disappointing, because it's never going to improve, like, if nobody cares,
Yeah, and
because
it
like those
just
mitigations are what makes like exploitation more costly for attackers, and if they're just not present, then you're giving them, it's like a free spot on a bingo card.
yeah, it is a free spot on the bingo card because, as I said, it adds to the cost of developing an issue. Now, of course, like I said, like the root issue is the fact they just have bad code. Like that is the root of the issue that also needs to be solved. But these things like enabling NX, ASLR, these are just really quick and easy wins that can usually be implemented as quick and easy. It is hard to say. Like maybe there is a reason that they have for it in terms of how they're implementing something. Like, oh, everything is like some crazy JIT stuff, so they can't actually do NX or something. Even that I don't think is a good excuse, but like these are easy things that you can apply universally that add a pretty reasonable layer of defense. They're not perfect. They can easily be bypassed. I mean, we talk about bypassing things like that all the time. But they should still be there. It's kind of like, okay, I'm just going to leave my door open because somebody can bash it down with a battering ram. Might as well just let them in.
I mean, the fact is, a lot of these like mitigations can literally, all you have to do is pass a compiler flag. That's it. The compiler handles everything for you. So it's really like negligent to not use them at this point. There's
Like I
not many
said,
good
they
arguments.
could be on some old setup, like some crufty code. That's why they can't really do it. Like
But I don't
there
think
are
that's a good
reasons, but
excuse.
no, it's not a good excuse. I just think it's a reason why. Like it is an explanation. I don't think it's a good excuse.
Yeah. So we'll move into our last topic, which is a first part of a 3-part blog series on an Android full chain exploit, including a Chrome bug, a Sandbox escape, and a kernel exploit. This first blog post covers the kernel exploit portion that affects Qualcomm devices. So this wouldn't affect, the Exynos phones. I still don't know how to say that, but yeah, it's affecting the Qualcomm devices. And it's around KGSL and the ioctls that are used for importing GPU objects and mapping user memory to create a shared mapping between user land and the KGSL driver.
So just so if anybody doesn't know, KGSL is kernel graphics support layer.
Yeah. So when you get into the specifics of DMA and communication with the GPU, it does get pretty complicated pretty fast. Basically, when using the shared mapping, there's 2 types of mappings you can supply. And that's because of legacy support, basically. You can supply a DMA buffer through the ion allocator, which is one of the many custom allocators in Android, or you can provide a raw memory address that the kernel will attempt to create an ion object from itself. And when you set up a mapping, it gets assigned an SG table, which they don't elaborate on what that is exactly, but I believe it stands for scatter gather table, and it's used for scatter gather IO. The problem comes when the cleanup happens for the internal map or entry object. If something goes wrong and a fail path gets taken when it goes to clean up that shared memory entry. So if it's mapped as a DMA buffer, it'll attempt to null out the SG table field of the entry to avoid freeing it, because in cleanup it will free that SG table. Because usually it is owned by the memory entry. But in the case of it being mapped as a DMA buffer, it will avoid freeing that by nulling it out because it doesn't own that, right? It's owned by the DMA buffer, not the memory entry.
Yeah, and just kind of add on there, like this destroy ion call that happened. So because it's the DMA buffer calls destroy ion, that's the one that clears the SGT. So when they don't want to double free it, because shared mem would try and free it there too.
Yeah. The problem is on the 4.12 kernel, code was added to store a reference on the SG table in a DMA buffer attachment when a DMA buffer is attached to a device. And that reference isn't removed since the destroy ion function never gets called, which means you end up having a dangling pointer to it. Anywhere that uses that has a UAF path. So they give a lot of background information on how that UAF could be abused to get an info leak as well as code execution. I'm not going to cover all of it because there's a lot there. The long and short of it is they basically use it to get control over a scatter list, which is a child of the scatter gather table, which is eventually used by memcopy to move memory around with DMA. It was difficult to find an object to spray to abuse this bug, though, because obviously where you're corrupting like a DMA pointer that gets passed to memcopy, you need to make sure it's a valid pointer to valid data, or shit will blow up when it gets to use when it goes to that memcopy, right? It has to be a page that's actually allocated. If you try to use an unmapped page, then it's gonna triple fault. Now, funnily enough, this is yet another place where we see CodeQL being leveraged. I guess that isn't a huge surprise because this is a post on GitHub Security Lab. But by using that and looking around, they eventually found they could spray opening of a binder object, and that would get a file structure allocated and put in the UAF slot, which they could use to smash the file operations table to hijack the program counter. Now they do talk a little bit in the end about CFI and I think how they got around that, though I'm not really going to cover that here. But yeah, I mean, there's a lot of background information here. It's a cool bug. I do wish the write up was written a little bit better. I think there is a little bit too much background information. It is like there's a lot to go through there if you want to read through it.
The background information is great. It makes these write-ups useful. So like I wouldn't want to have them just get rid of it. At the same time, like a summary, a better overview is maybe sometimes nicer to see too. It's a long read. I will mention that they did use CodeQL, but unfortunately it wasn't actually too effective. They were using it to try and find basically another object that they could use with the UAF. They kind of set it up so they looked for a object from like K-Malloc or family. with the size kind of putting in the same bucket as the SG table and had a pointer as the first field. They didn't find some that was suitable using this, unfortunately, but they do still kind of include the query that they use to look for it. And this is actually, I think, one of the really nice things about CodeQL in general is, it's not just about finding vulnerabilities. You can use it to kind of query just code in general, and that's useful when it comes to like these large code bases. In this case, it doesn't seem like it was the most effective thing. They found some that came kind of close, but not quite perfect. There was one trick that they used, and that was in trying to get a out of memory error. There we go. Getting the freed object with a fake out of memory error. I thought this was kind of a fun little trick that they used for this. So when doing the allocation for the shared memory, they give it a memory. They kind of give a description of the memory, and that includes in their flags the alignment for all the memory that they should be provided with. And in that alignment, in order to get out of memory, they didn't want to actually fill up the entire memory and have like a real out of memory issue, because that would obviously cause stability issues, and they needed the error to happen like in a very specific location in between a couple calls. Like they needed to happen on one specific call, otherwise things wouldn't be allocated correctly. So what they ended up doing is using this alignment and basically setting the alignment to I don't want to say the maxent because it's like 1 followed by all the zeros. So like just setting that first bit. So that way there's only like 2 addressable addresses that they could be provided with, which means it's very easy to kind of fill up that memory without actually filling up all the memory. I just thought that was kind of a neat little trick they used here.
Yeah, I did want to like quickly kind of agree with what you were saying with CodeQL. It's not just a vuln research tool; it's an exploit dev tool too, which is kind of rare that you find a tool that can cross both barriers. So, yeah, I mean, it's just over time, it's just showing like in how many different places it can be used.
Yeah, we're just becoming CodeQL shills.
Yep, we're gonna we're gonna have to start putting that in all of our titles and have a sponsored image or something. But yeah, no, like CodeQL is really cool. And so is this exploit, to be fair. I mean, this is a good post about how much work is involved now with modern exploitation. I actually saw a tweet that was kind of around this fact. They quote tweeted this link and said, I miss the days when you used to be able to just find like an int overflow or something in an ioctl handler every other day or something and exploit it. Like, this is a complex UAF, and it's due to a very like edge case, bad handling of an edge case in a very complex function, right? So yeah, I mean, if you want an example of what a lot of modern exploits are about, especially in the mobile space, this is probably a good indication of the types of issues that the field has been narrowed down to, basically. But yeah, with that said, I think we can move into shoutouts. Z, I don't have any shoutouts today. It's going to be a Z show for the shoutouts, so I'll let you cover them.
Oh yes, my own show. I just have a few kind of posts I came across that I didn't think were necessarily things that we wanted to fully cover during the podcast. So the first one here is exploiting a simple vulnerability. I think we talked about part 1. Do you remember if we talked about part 1.5?
I think we might have talked about 1.5 as well. It does ring a bell. If we didn't cover it, I know I read it.
Yeah, it might have been a shout out if we didn't. And now is part 2, where it's the same vulnerability from part 1, only they've made the exploitation a bit more difficult to kind of cover some more restrictions and how they might get around those. So still some interesting things to see there. Just we've already kind of covered the root of the vulnerability, so I didn't want to cover it in depth.
So just to add on there quickly, we did cover 1.5 as a full topic back in episode 62. Okay. So, yeah.
Well, so there you go. And the other thing, or the next one, is playing in the Windows Sandbox. Checkpoint Research basically did kind of a look at the Windows Sandbox. So this would be good if you want to start actually looking at breaking the Windows Sandbox. A lot of background information here, not really an exploit, just here's what's going on, how things work, how things are layered, what it's doing, all that background information that's just useful if you're going to get started. Doing your reconnaissance before you actually jump into the exploits. And my last shout out is Regexploit, DOSable regular expressions. We've talked about this RE-DOS stuff before. This is just a tool to actually check it, which I thought was kind of cool to see. Because we've talked about this issue, I think at least a couple times.
Yeah, I think 2 or 3 times we've probably covered like regex related DOS.
Yeah, so this one, it's just a tool that kind of lets you know if your regex is actually vulnerable, or that you can visualize and kind of see what's going on with, or find out what like the worst case is. So definitely useful for that, rather than kind of being able to just spot it and know the regex. I know a lot of people haven't bothered learning regex. I do think it's worth learning, but if you haven't and can't quite recognize all the bad issues, it's a tool that makes it easy. And with that, though, that is my last shout out.
All right, yeah, so that'll wrap up the episode. Thank you to everyone who tuned in. You can catch the VODs on Twitch or on YouTube, as well as some other platforms, which you can find in our Anchor 24 hours after the stream. I will be continuing some of the FreeBSD PS4 kernel exploit streams this week. They probably won't be as frequent as they were last week. I'm probably going to be winding them down a little bit in that respect, especially since Slursgovy released his implementation. I can kind of take my time a little bit more. But yeah, we will be doing some of those streams this week. Might even do one tonight. Follow us on Twitter and check out our Discord for notifications of when those streams happen, as well as anything else that we might cover, because we do sometimes do some other videos on our YouTube as well. But yeah, with that said, we'll be back next week, again at the usual time, 3 p.m. Eastern, 12 p.m. Pacific, and we'll see you all then.